everyone. Hello. Yes. Awesome. So how many of you are machine learning GDEs? I know I saw a couple, Vikram and Margaret, earlier today. Yes. So just a couple of hands. Okay. How many of you are interested in machine learning or deep learning? Okay. How many of you tried using TensorFlow for the original version and then ran away screaming? Because that was, okay, cool. Because I fell into the same boat. The original TensorFlow in 2015, when it was first open sourced, was really frustrating. Whenever you used it, it kind of felt like a cat scratching your face. The Python API wasn't straightforward at all. So we've done a lot with TensorFlow 2.0 to improve usability, to make it a little bit friendlier for people to get used to. And in less than 10 lines of code, you can start training deep neural networks. This will be a very technical talk. So if you have questions, yell them out. I would be delighted to hear them. But also want to let you guys know a little bit more about 2.0. So who am I? I am Paige. I do things on the internet. I just recently got hired as a TensorFlow developer advocate a few months ago. Before that, I was a software engineer in the office of the CTO at Microsoft for about a year, also doing machine learning things. And then before that, I was a predictive modeler and machine learning engineer for Chevron for 5 years. And before that, it was NASA projects. So my background is very research focused. But also very, very much into predictive modeling and into data science before data science was a thing. TensorFlow was kind of a natural fit, a natural home within Google, and I really, really enjoy it. And developer advocacy for TensorFlow works pretty similarly to cloud developer advocacy for cloud. The only difference, I would think, is that TensorFlow is an open source project. Which means that I get to talk about it working on any platform on a variety of devices. And it's all free, which makes people very, very happy. Yay, free. It also works great on Google Cloud, I should say, too. So just to say. So what is TensorFlow and why is it important? This is a collection of starred locations for GitHub. We have about 80 repositories on GitHub now on the TensorFlow Organization. And all of these little orange dots are places in the world where people have starred that GitHub repository, which doesn't really mean much, I suppose, including somebody in Antarctica. And I don't know quite what they're doing. Maybe like deep learning on penguins or something. But yes, so TensorFlow all over the world. It's been incredibly successful. The growth's kind of been amazing. We've had 41 million downloads, 50,000 commits, almost 10,000 pull requests, and 1,800 contributors doing everything from documentation to like contributing loss functions to small snippets of code. So it's been really, really exciting and kind of powerful to see that this product that we've used at Google has such traction in the external community as well. And if we look back on the timeline since it was open sourced, you can see things like adding high-level APIs, so estimators, and also Keras as a version 1.4. We've created something called TensorBoard. We've done cloud bigtable integration. And really, TensorFlow has just kind of grown as an ecosystem as opposed to just this single repo with one product. And we've used it in Google in a variety of ways. So in our data centers, it makes them more efficient with an AI control system that delivers energy savings. We've used it for localization for Google Maps. You might have also played with the augmented reality thing with the little fox running around, and that's also powered by TensorFlow. And then also portrait mode on Google Pixel. So basically, every product that you're using for Google is probably embedding TensorFlow in some way. Like Gmail, the autocomplete for your messages, that's TensorFlow. Autocomplete on your phone, that's TensorFlow. If you've noticed that speech to text, whenever you speak into your Android device,
so much better.
Yes, it has, and absolutely. So the reason that it's gotten so much better is because TensorFlow is actually able to deploy models to mobile devices now. So instead of having to go and ping a server somewhere and wait for a response, you can actually just do inferencing directly on the GPU for your phone. It's amazing. And sort of one of the reasons why I was most excited to come to Google. But so even though these are great, business-focused use cases, we've also seen really interesting applications that we could have never imagined from the community. So this is a CodePen that was created by Tiropa, or at least that's like his handle, Tiro, who's a brand new machine learning GDE. He's created a way for you to sort of select beats and then to automatically generate a melody. And you can imagine if you're a musician being able to create a melody and then create a bass accompaniment or a drum accompaniment, or the Google Doodle that was just recently with J.S. Bach, being able to select a few notes and then create multi-part harmonies. All of that is created using TensorFlow. And then we also have amazing medical applications. So this is something called AlphaFold. There's like this Olympics of protein folding. I didn't even know that was a thing. But apparently, DeepMind, one of our research organizations, was able to build a model that completely blasted out of the water every medical researcher that was competing in that competition or had competed in that competition historically, their very first try. So, I mean, that's exciting. I mean, if you're not in the medical field, maybe. But it's also, when you start thinking about the kind of mind-boggling applications, it frees researchers up to do such more interesting work, right? Like, so instead of having to go through the tedious process of, weeks or months trying to architect some sort of protein folding model, you're able to do it with 10 lines of code on, a cluster of GPUs or TPUs. So lots of different applications, variety of fields, everything from art to science to optimization. And like I said, even though while it's been able to create all of this, wonderful things, it was a little bit painful to use. So this code is from the first iteration of TensorFlow. It's not at all straightforward. You see some things like sess.run, you initialize some variables, but you're not allowed to inspect them, right, until you assign some variables, and you're not allowed to inspect them until you initialize them. There's even a typo, I think, in this slide, and that when you start training it, it's not necessarily, when you're feeding in your dictionary of data, it's not being batched appropriately, and so even though it runs, it kind of silently fails and gives you back a response that wouldn't necessarily make sense or be correct. It's like Perl, right? Like you type something in, you type something in and it gives you a response. No matter what you type, it gives you a response. It just might not be what you want. So at any rate, we've learned a lot since that. We've learned that if you're going to be creating a developer-facing product, you should probably have eager execution by default, especially if it's Python. Are there any Python people here? Yes, so being able to have that REPL experience where you type something in and you get something back, that's so huge. It's important. It's immediate gratification. And if you're a developer, that's what you need to experience instead of building this static graph and then inspecting it afterward. So now, if you want to add two values, you can add two values. And it feels very much like Python as opposed to before where you had to have 10 lines of code to even add two tensors. We've removed duplicate functionality. So I believe the original TensorFlow ended up with something like 4,500 endpoints. Now we've got more like 1,000, which feels a lot more tenable. We've removed the duplicate functionality. We've created a consistent syntax. So instead of tf.foo, we now have tf.math.foo or tf.signal.foo. And then we've also included the full lower level API. So if you want to stay high, that's fine. If you want to subclass Keras, that's also OK. But if you still want that sort of lower level control that you'd experienced previously, you can access all of it with raw obs. I don't know why you would want to unless you were a researcher, but go for it, dude. And then the other bit, right, is that we've centralized everything around this component called saved model. So before, there were a number of ways to kind of export models, and you ended up with this sort of terrible protobuf experience, and because Google loves protobufs, I don't know. But now everything is kind of a saved model that can be deployed to a server with a TensorFlow serving, to a mobile device or an embedded device with a TensorFlow Lite. We now have EdgeTPUs that you're able to port entire models to. And you can do, hundreds of frames per second for inferencing. We have TensorFlow JS, so you can put models in a browser, yeah, which is also really, really stinking cool. And we have other language bindings. So if you don't want to use Python, you can use Java, you can use C, you can use Swift, you can use Rust. There's a special interest group with a Rust guy, and I think the special interest group is one person. He talks to himself. He's specially interested in that. But yeah, we have Rust support, and that's it's crazy. And if you're an R person, we also have a great Keras R binding. And so like I said, the training workflow, we have a number of products that allow you to do data ingestion and transformation very simply, model building, training, and then saving as saved model. And the saved model can be deployed throughout the entire TensorFlow ecosystem. So let's take a look at some examples. So the first thing that you need is data. And often you want to validate results or test your new ideas on a common public data set. So TensorFlow datasets, if you have familiarity with scikit-learn, it allows you to easily ingest massive amounts of data very, very sort of seamlessly, maybe not necessarily quickly because you're pulling in terabytes of data at a time. But combined with TF data, it's a very, very straightforward path for data ingestion for all of your models. And those are some of the examples of the data sets that we've added recently. Last time I checked, we had about 95 pull requests for data sets that were waiting to be merged. So there are a lot more. And when I say that these are sizable data sets, I mean something to the effect of we have a 300,000 X-ray data set from a Stanford research group in machine learning. We have a 10 million record row of Amazon purchases. So if you wanted to create a model that would be able to estimate what a person would buy, then you would be able to do that. And even more. So everything from video to images to sound, all available for you to use for free. And we also love Keras. So Keras is the only thing that made TensorFlow sort of painless for me to use. And I'm kind of curious, has anybody here tried using Keras? Any chance? A few hands? OK, cool. That's your homework. Go and take a look at that. Keras is sort of the format that all of our that we're recommending everyone use for TensorFlow, and it is our recommended higher level API. And with Keras, you can express the model with layers just as you're thinking about it. So this however many lines that you see on the screen here, this is all that you would need in order to deploy a deep learning model to production today. So instead of the 200 lines of boilerplate that you might remember if you tried to use TensorFlow a couple of years ago, we've condensed it down to this 10-line experience. Yeah. Yeah. Excellent. And since we're Google, we made it scale. And the way that you do that is just with an additional 2 lines, right? So if you want to scale across a cluster of GPUs or a cluster of TPUs, you would just have to include TF distribute mirrored strategy and then place your model within the strategy scope. This also works in Collab and with TensorFlow Hub. And Collab, if you don't have experience with it, It's a way for you to use Jupyter Notebook environments with free hardware accelerators. And I did say free. So if you want to create a notebook, hook it up to a GPU or even a TPU, and try it out for up to 12 hours, you can. Please don't use it for Bitcoin mining. We did have problems with that before, but we have checks now, I think. So just please don't. And TensorFlow Hub, I should probably say, we don't expect everyone to be able to architect your own model. That would be silly. It would require a great deal of data, a great deal of time, and a lot of very expensive hardware. So TensorFlow Hub is kind of a marketplace where you can just take bits and pieces of other people's models and stitch them together for your own purpose. So all of those use cases that I was describing before about sort of energy optimization and being able to automatically detect spots on faces or being able to automatically detect poses or detect cats in images or hot dogs or whatever the kids are doing these days. All of those are available to use from TensorFlow Hub for free, again, so just saying. And so just as kind of a recap, we have high-level building blocks with Keras and estimators, and full subclassing with custom loops if that's what you need. And if you wanted to build a custom encoder for machine translation, it would just look a little bit more complicated, right? So if you wanted to do something that didn't come prepackaged, then you would just include these customized training loops to get full control over the gradient computations. And we also include something called TensorBoard. So if you want to be able to inspect your model, to be able to actually understand what it's doing as it's cycling through all of the data for each of these epochs, this comes out of the box with TensorFlow as well. So you can take a look at the images, how your model's making its decisions. You can do preferential highlighting on pixels and images to say like, hey, we're deciding that this is a cat because it's got a super long tail and pointy ears. That is all possible with TensorBoard. And we have built-in performance profiling as well. So if you want to understand what your GPU utilization or your TPU utilization looks like, you can do that with Keras callbacks. More importantly, and this is one of my favorite things, we're focusing more and more on documentation, tutorials, and quick starts. So instead, yes, thank you. So instead of sort of expecting you to, don't go alone, take this sort of thing, we're making it that we're adding many more sort of accelerants for it to be easy for you to get started with building your models. And we also sort of increased performance. So 1.8 training speed up, 1.6 training speed up with TPUs, and then also some partnerships with Intel Skylake. And sorry if I'm rushing through some of this. I want to have enough time to get questions for you guys. And then, as I mentioned before, we've got about 79 repos in the TensorFlow organization. It's everything from agents for reinforcement learning, to probability if you like statistics, to ranking if you want to be able to do custom ranking for objects or for sort of things that you would purchase in a shopping basket, federated for security, privacy, for not being able to make it so that if you wanted to do deep learning on data that you can't see, if your customer wanted to keep their data privacy secure, you would still be able to do that. And we want to be able to deploy everywhere. So not just servers, but also edge devices, mobile devices, and browsers with TensorFlow.js. We also have an extended end-to-end platform for managing every stage of the machine learning lifecycle. And if you're working in industry, this is huge. So I mentioned before that I was a data scientist and a machine learning engineer at Chevron. The problem with machine learning there is that if you make an incorrect assessment, then something blows up, right? And I'm not joking. So there were instances at rig sites where if you didn't have appropriate checks on your model, and it didn't catch that maybe you should change your pressure or you should change sort of the RPM, the rotations per minute of your bit, then somebody might have lost their life. Right? So being able to make sure that as your model's retrained, the data's consistent, that it's still making correct assumptions, is really, really vitally important. And for this, we've created something called TensorFlow Extended, which allows checks for data validation, for the deployment, and then for rechecking your model to make sure your accuracy stays the way that you need it to stay. And this is what we've been using at Google internally. I probably should have mentioned that in the first place. Like, why would we open source TensorFlow? And it's mostly because Jeff Dean said so. Well, that's not a joke, actually. So it was originally architected as something called distbelief. And it was very beneficial to Google, especially in terms of search and in terms of ads. It was created by Jeff and a team of other engineers. And in 2015, he kind of stood back and was like, this has been so useful for us. And really, we think it could be useful to the world. So let's open source it. And it wasn't just sort of the engine, the numerical computation component, which is TensorFlow Core, but they also wanted to open source the entire deployment pipeline. So if you're wondering like what's being used to power everything at Google, since we're an AI-first company, we're a cloud-first company, it's this. And we've made it available to everybody if you want to use it for free. So that's TensorFlow Hub. And all of this was announced at the Dev Summit, I guess about 3 or 4 weeks ago. And TensorFlow Lite. So another really, really exciting announcement is that we have EdgeTPUs that are freely available to the public. So if you want to use one, they're about the size of a fingernail, and you can deploy an entire TensorFlow model to them. And they're very, very fast. That's the point of this slide. And so that's, again, JavaScript, an out-of-the-box model. If you wanted to see a CodePen of this, I'm happy to share one afterwards. But TensorFlow JS is very, very popular, allows you to deploy models to a variety of platforms. And to recap everything we've shown you so far, TensorFlow has become a full ecosystem for a variety of languages, variety of platforms. And if you want to upgrade, we've made it easy. We have an upgrade script from 1 to 2. All you have to do is export a Python file or a Jupyter notebook. You run the upgrade utility on it. It exports a report.txt file that tells you about renamed API endpoints, added keywords, and then renamed things that have been renamed with some sort of escape to backwards compatibility mode. And then once the conversion's done, you can run your model the same way that you would normally. Yeah, excellent. Thank you. So yeah, all of the historic code that you have is still available for you to use. This is also something that I want to point out. One of our machine learning GDEs, Sergey, created a website that allows you to look at the diffs for first iteration TensorFlow models and second iteration directly in your browser. So it works for Jupyter notebooks and then also for Python files. And he's running this service for free on GCP, which is kind of amazing. And if you want to learn more, so I guess that's the money slide or whatever, tensorflow.org/alpha. And it's got tutorials, migration guides, detailed documentation, timeline. We should release it by spring. Spring is a nebulous concept. And then there should be a final version by the end of the year. But if you're doing this, I want to hammer in, you're on the bleedingest of edges because all of the engineers internally are also migrating at the same time. So if you come to our upgrade meetings, you're going to be talking to TensorFlow engineers and to other Google engineers that are going through the same struggles or sort of going through the same delights and can share them. We have an online project tracker in our GitHub repo, so if you want to find out when a feature is going to be added, there you go. And it's also all about communities. So Google Summer of Code, we've launched that this year. If you want to work directly with TensorFlow engineers and get paid for it to work on an open source project, there you go. It's one of my favorite things about Google is being able to work directly on open source projects wherever you are in the world and to receive money. The Powered by TF Challenge, we're giving away $150,000 in prizes, mostly associated with the TensorFlow World event that we're having in the fall. But if you create a project using TensorFlow 2.0 and it's selected, you get to present it to Jeff Dean, essentially. So that's pretty nifty. We've got a lot of free courses, so if you want to learn things, we have 14 segments planned on everything from TensorFlow JS to TensorFlow Lite. It's all free. And then we're also having a global doc sprint on April 6th. Margaret is planning that and off to the site. And myself and Sergey. And if you want to host a meetup in your neighborhood, let us know. And yeah, so that's how you would get started with TensorFlow. And if there are any questions, I would love to hear them.